This topic is about histogram. Now, what is histogram? What is the definition of histogram? Well, histogram is a display of statistical information that uses rectangles to show the frequency of data items in successive numerical intervals of equal size. In the most common form of histogram, the independent variable are plotted along the horizontal axis and the dependent variable are plotted along the vertical axis. The data appears in histogram, or how the data appeared in histogram is it is actually in shaded or colored rectangles of variable area, which many people are confused between the difference between the bar charts and histogram. In bar charts, it is always a comparison between data. So this rectangle is a comparison between another rectangle, and so on and so forth. But here in histogram, it is always in successive numerical data. Therefore, it has no gaps between the rectangles because again, it is in successive numerical data. The data is in successive numerical. It is always in successive numbers like 10 to 20, 20 to 30, 30 to 40. So that's everything about the histogram, the definition of histogram.
I'm going to tackle about making frequency distributions and histogram by hands. Generally, statistician will use some kind of statistical program like R or Minitab to make their statistical graphs. However, it is still surprisingly common to see textbook do everything by hands, and in the end, learning how to make histogram by hands is a great way to get better at reading them and figuring out what the problem is when a computer or calculator gives you something you don't expect. In this lesson, we will look at the step-by-step process of making frequency distribution and a histogram. So, you can see there is a data set, and I want and put the numbers in order, which will make everything much easier. To make histogram by hands, we must first find the frequency distribution. The idea behind the frequency distribution is to break the data into groups so that we can better see patterns. Steps to making frequency distribution. Step 1. Calculate the range of the dataset. The range is the difference between the largest value and the smallest value. We need this to figure out how much space we need to divide into groups. So 65 in our table is the largest value and 12 is the smallest value, so we need to subtract them. 65 minus 12 equals 53, and 53 is our data range. Step 2. Divide the range by the number of groups you want and then round up. Doing this allows us to figure out how large each group is. But the question is, how many groups to have? Too many? And our graphs and table won't be much better than a list of numbers. Too few, and the pattern will be hidden with too little details. Often a good number of groups is 5 or 6, although there are some rules that people use to decide this. More often, people will let the computer decide and then adjust if they want to. Well, textbook will tell you how many groups to use. But if you are working with the data set yourself, you'll have to see what the graphs look like, and before you can be sure you choose a good number. So let's say that we choose to have 6 groups. If we do this, then 53, which is our range, and 6 is our chosen group. So 53 divided by 6 equals 8.8. The number we just found is commonly called the class width. We will round this up to 9 just because it is easier to work with that way. A computer will probably keep 8.8, so be aware that sometimes you will see this number as a decimal. So remember, people who are doing this by hand always round up even if it is 8.1. Now let's go to step 3. Use the class width to create your groups. I'm going to start at the smallest number we have, which is 12, and count by 9 until I have my 6th group. For example, my first group will be 12 to 21 since 12 plus 9 equals 21. My next group would be 12 to 30 since 21 to 30 since 21 plus 9 is 30. and so on. I put this in a table and label them classes, and I will also add frequency to the table. So you see, right? The in the left side there is a classes 12 to 21, 21 to 30, 30 to 39, and so on. And then right side is the frequency. Step 4, find the frequency for each group. This is probably the most tedious and the main reason why it is unrealistic to make a frequency distribution or histogram by hands for a very large dataset. We're going to count how many points are in each group. Let's start with our first group, 12 to 21. We want to count how many points are between 12 and 21, not including 21. You can see the overlap between the groups, right? That's to count for decimal, and we keep it even when we don't have any. The right hand endpoint of any group isn't included in that group. It goes in the next group. So that means that 21 would be in the second group, and 30 we have would be counted in the third group. Back to the first group, 12 to 21. I have circled the points which would be included in this group. So 12, 14, 14, 14, 16, 18, 20, 20. So that is the points include in the first group. All right. Now I update the table with this information. So the class of 12 to 21 have a frequency of 8. Continuing with this pattern, each group have different colors. So the first group is 8. As you can see, there is 12, 14, 14, 14, 16, 18, 20, 20. That is the first group. The next is 6 in the blue one. Then yellow in the third group. There are 6 points. Then in the fourth groups, there are 6 points. Then 12 for the fifth. Then 6 for 2 frequency. So I update now the table with information. The classes 12 to 21, 8, 21 to 30, 6, 30 to 39, 6, 39 to 48, 6, 48 to 57, 2, and 57 to 66 is 2. So that's it. We complete the table. Now, to make histogram from this, we will use the groups on the horizontal axis and the frequency on the vertical axis. Again, we will use the groups on horizontal axis and the frequency on the vertical axis. Finally, we will use the bars to represent the frequency for each individual groups. With this data, the finished histogram will look like this one.
Okay, so next I'm going to discuss about how to read a histogram. So if you're involved in the observation of statistics or looking at any kind of technical data, you may need to be able to read a histogram. So for beginners who need to understand what the histogram is all about and how to interpret it, here are some of the important steps. First is to read the axis of the graph. The x-axis is the horizontal axis and the y-axis is the vertical axis. Both give you essential information to reading the histogram. So many histograms show you the results of the frequency of an occurrence and will have a y-axis indicating frequency. The x-axis will tell you the average ranges into which the data have been grouped. For example, a histogram detailing the frequency of heights of pitchers in professional baseball will have an x-axis of height and a y-axis of frequency. Next step is to identify the ranges used. So the data is grouped into ranges or bins for graphing. Choosing the correct bin size is important in yielding a graph that will help you interpret your results. You want to choose the ranges that are not too broad or too specific and allow you to see an underlying pattern of frequency in the data. For example, the average height of a professional baseball pitcher is 6'2", but there will obviously be exceptions because the ranges of height will likely be between 5'6" and mid 6'6". The bins should only vary by about an inch or two. So another note on the ranges, the very first group may range from 5'6" to 5'8", but it does not include 5'8". Each group includes everything up to the beginning of the next group. And lastly, the last step is to use the top of the bar to read the frequency of the group. If you want to know how many times an event occurred within a specific range, simply look at the top of the bar and read the value of the y-axis at that point. For example, looking at this histogram, the number of players in the range of 6 to just under 6'2" is 50.
The examples and application of histogram in the modern world. So, histogram is a graphical display of numerical data using bars of different heights. It is similar to bar chart, but a histogram groups numbers into ranges. So, first example is in the government. In the government, by the use of histogram, the government can provide us the update of increasing number of our population. And also, by the help of histogram, the government can show us the mortality rate of a particular disease. So next example is in the field of work, particularly in the companies. So the histogram can give us a good overview of the data. And with the help of histogram, the company can determine how many buyers will obtain their product. Also, with the use of histogram, they can manage to see the progress of the company. Histogram can provide guide to the company on what improvements they will make. And lastly, histogram is used to display statistics in business, economics, and other disciplines, and provide a useful tool for analyzing data and trends.
Now for the educational application of histograms in the modern world. So here, histograms can be used as first, teaching materials, and second is for group reporting. So in the field of education, the student's response to the teacher's learning strategy is very important. With the use of histograms, we can achieve a much more clearer and a fun way of conveying information to the learners. Next is application in medicine. So histograms can play a vital part in medicine since it conveys data and information. Lives may be at stake. So first is histograms can be used as patient report. So let's say for example in the premises of a hospital is trying to conduct like the frequency of patients who are diagnosed with diabetes as per the example in the PowerPoint. Next is histograms can be used as experimental research. So from the word itself, experimental, experiment. So here, histograms can be used as a collection of data for a specific specimen and another specimen, or for variable 1 and for variable 2. Next is, histograms can be used as for the health programs. So here, to conduct a program, of course you would need valid data to support it, right? So let's say for example, we're trying to launch a Fight TB awareness program. So the histograms can be used as the frequency of maybe people who are diagnosed with tuberculosis for them to know the scope and coverage of their program. So that's it for the application of histograms in the modern world. Thank you.
Applications and websites we can use in making histogram. The most common and we can easily find in our personal computers is MS Word. So in MS Word, we have to click Insert in the menu bar and then click charts. After clicking charts, MS Word will show you a pop-up command which you are going to choose histogram, and then click OK. After clicking OK, MS Word will show you a blank histogram and will open Excel. And in Excel, you're going to input your datas, and this will reflect on your histogram in your MS Word. And you can also edit your histogram, its color, the fonts, and everything using MS Word. Websites we can use in making histogram. So these two websites will let you make histogram and can also input your data, edit it, and save it. So this is good if you are using your phone and you don't have the MS Word application in your phone.
Significance of histogram. It provides visual representation of data distribution, displays large amount of data, and frequency of data values. The median and distribution of data is determined, and it shows outliers. It is used to make predictions of the future based on the data. It helps us to know what or where the problem might be. It shows outliers, in which it indicates faulty data, erroneous procedure, and areas that might not be valid in order for us to make quality improvements. So that's all. Thank you.